Since there is a video already up on conversions, percent composition, etc., we are just going to be covering the empirical formula, molecular formula, and molarity in this video. Alright, so if you want to look at the review sheet, we're starting at number 15. And that states that we're trying to find the empirical formula. We have 88.8% copper and 11.2% oxygen. Following your chart up here, okay, remember this because you will use this for both empirical formulas and molecular formulas. Alright, so first thing we do, we have percent composition. So copper is 88.8% and oxygen is 11.2%. Okay, all we have to do to get grams is we're going to drop the percent and add the grams, so we have 88.8 grams of copper and we have 11.2% oxygen. Or grams, excuse me. Now we're going to divide each of these by their molar mass. So copper is 64 grams per mole. And remember, grams per mole is just how we can state molar mass. And oxygen, 16 grams per mole. Now if you'll notice, we can do this using the train tracks dimensional analysis, but if we write grams per mole, quite simply those cancel out and we're left in moles, which if you're following up here, that's where we need to get to next. And we end up getting 1.388 moles of copper, and we end up getting 0.7 moles of oxygen. From here, we're going to look at which number is the smallest. We see that oxygen is the smallest, so that's going to be our denominator. So divided by 0.7 divided by 0.7. Well, we know this gives us 1. Alright, if we plug this into our calculator, it gives us 1.98, which would then be turned to 2. So what these are telling us is that we have 2 coppers in this formula and 1 oxygen in this formula. Therefore, I'm going to use these numbers and we're going to write our empirical formula. And that's going to give us copper oxide, Cu2O. And that should be your final answer for number 15. So number 16 states that we have carbon at 40%, 40% hydrogen at 6.7%, and oxygen at 53.3%. Oh, let's erase that and get our correct 53.3%. Alright, go ahead and compare your notes against this, or go ahead and try finding the empirical formula. So we're changing these to grams, 40 grams, 6.7 grams, 53.3 grams. And remember, next we're dividing each of these by their molar mass, carbon being 12 grams per mole, hydrogen being 1 gram per mole, and oxygen being 16 grams per mole. Alright, once again, all our grams cancel out. So we have done that, and right now we are getting our moles, which turn out to be 3.33 moles of carbon. Hydrogen ends up being 6.7 moles, And oxygen, lucky us, ends up being 3.33. Now notice oxygen and carbon are there, the exact same numbers, which is great, which means our ratios are going to be easier to calculate. So if you're choosing the correct molar ratio, we should have a denominator of 3.33 for each of these numbers. Obviously gives us 1, so we've got those two. And even without a calculator, you can probably guess that 6 divided by 3 is 2. Obviously we're going to get a little over 2, but round to the whole number right there. And so our empirical formula right here, all we have to do, carbon, well, we know we have 1, right, we have 2 hydrogen, and we have 1 oxygen, so we should have CH2O. Right there, here, I'll highlight that bad boy for you. There's our empirical formula. Onward to 17, and we have 92.3% carbon. And hydrogen is going to make up the remaining 7.7%. Alright, so from here we're going to move to grams. 92.3 grams, 7.7 grams. We are going to divide by the molar mass of each substance. Carbon is 12 grams per mole, and hydrogen being 1 gram per mole. Grams cancel out. We're left with moles, and that is going to give us about 7.69 moles and 7.7 moles. Now if you rounded carbon to 7.7, perfectly fine. Right here I'm just going to use 7.69. Obviously that is going to give us 1 for each. Then that is going to give us each as our empirical formula. Now on to 18. We have iron at 70%, carbon at 30%. Once again, let's follow the steps. Notice I've taken away the diagram. Let's go ahead and try this on our own. The molar mass is going to be 56 grams for iron, grams per mole, and 30 grams of carbon divided by 12 grams per mole as the molar mass. And let's go ahead and get our moles, which we end up with 1.25 moles of iron, and we end up with 2.5 moles of carbon, which we have our lower number up here being iron, so that is going to become our denominator for our molar ratio. It's going to give us 1 iron to 2 carbon. So our ratio is 1 iron for every 2 carbon. And there we are, empirical formula. Number 19, hydrogen, oxygen. Hydrogen, we have 5.88%. Just going to do this, change it to grams. Oxygen, we have 94.12, 4.12% changes to 94.12 grams, 16 grams per mole, and 1 gram per mole. Cancel them out. Wonderful. We are now to 5.88 moles of hydrogen and 5.88 moles of oxygen. I'll write this out, but you should already be able to see that we're going to divide by 5.88 because it is the lowest and the only denominator we have, which means a 1-to-1 ratio for this compound, which means we have 1 hydrogen and 1 oxygen, and that is our beautiful empirical formula right there. 20. We go with chlorine, which is 38.7%, 0.7%, and we have fluorine, which is 61.3%. Change them to grams. Should be masters at this now. Alright, which is going to give you 35 grams per mole. That's the molar mass of chlorine, and the molar mass of fluorine is going to be 19 grams per mole. Cancel out those pesky grams, so we're into our moles. And that's going to give us, for chlorine, a 1.11. Count for moles, and the number of moles in fluorine are going to be 3.23 moles. Going to divide by 1.11 since that's our lowest number of moles. And that is going to give us 1 chlorine to every 3 fluorines. So the empirical formula is then ClF3. Right there. 21. We have phosphorus and bromine, which phosphorus we have 7.19%. And for bromine we have 92.8%. Change them over to grams, 7.19 grams, 92.8 grams, and phosphorus has 31 grams per mole for its molar mass. Bromine's molar mass is going to be 80 grams per mole. Once again, we have our grams canceled out. Let's get this going. Phosphorus, you should end up getting 0.232, somewhere in that range for your moles. And for bromine, you're going to get 1.16 for your mole count. We can see a very small number of moles up here. Let's use that as our denominator. Oh, that division is nice. We have 1. Alright, and that is going to give us 5. Okay, so what does this empirical formula look like? Phosphorus, we have 1. Bromine, we have 5. And please keep this because you will need it for our molecular mass questions. Here, once again, I am going to skip a step right here. Look at me. We have 30.4% nitrogen, which, there we go, first step done. Oxygen, 69.6%. I'm just going to change those to grams real quick. Nitrogen is 14 grams per mole.